We physicists have waited 100 years since 1916 for this photograph. Both Voyager 1 and Voyager 2 have served their country and its people well since their launches in 1977, and they continue to pave the way for important scientific research today. These probes are used to investigate the active volcanoes on Jupiter's moon Io, or capture stunning images of Saturn's rings, but today they are exploring the unexplored waters beyond the heliopause. Something extraordinary beyond the edge of our solar system was recently identified by Voyager 1, leaving the scientific community both intrigued and confused. Michio Kaku speculates that extraterrestrials might have something to do with this. Where does the Voyager spacecraft stand right now? What has it discovered? Let's find out. Some concepts are simply difficult to comprehend, even with a smartphone and Google at your disposal. Consider the unlikely notion that energy is emitted in quanta or discrete packets rather than continually flowing. Or the depressing hypothesis that the universe as a whole, which spans 93 billion light-years, may only be one among many parallel universes. In this situation, Michio Kaku chips in. The theoretical physicist has established a successful second career as a mass-market science popularizer, simplifying for the general public some of physics' most complex and esoteric ideas, including quantum theory or the multiverse, laser cannons, starships, aliens. Since he was a little boy in Northern California, watching Flash Gordon and attempting to make sense of Einstein, Michio Kaku has been preoccupied with the future. He always knew he wanted to work in physics because, as he puts it, scientists and engineers invent the future with their innovations. Kaku was granted his request. As he matured, he became a well-known physicist and science communicator, recognized as a co-creator of string field theory. He's also the author of a dozen science-related publications, the most recent of which is The Future of Humanity, Terraforming Mars, Interstellar Travel, Immortality, and Our Destiny Beyond Earth. The theoretical physicist discusses the inner workings of the multiverse, the long-sought endeavor to integrate all the forces of existence in a single equation, and the book that even Albert Einstein couldn't finish. His most recent best-selling book, The God Equation, details the lengthy effort to develop a theory of everything, which would integrate quantum theory with Einstein's general theory of relativity, and maybe lead to new insights into space and time. Nearly 95% of the cosmos is yet unknown, and new forces and unusual particles are still undiscovered. We have amassed a vast corpus of knowledge about the universe around us over the course of human history. We have created elegant mathematical formulae that capture the universe at its most basic level. Strong telescopes allow us to observe both the beginnings of new galaxies and very old galaxies. Although we understand the Big Bang theory of how the universe originated, the facts we have accumulated in particle physics and astronomy indicate that our understanding of the cosmos is still extremely limited. When we look up at the sky, we can see that matter is organized into galaxies and clusters of galaxies on the biggest scales. There are stars, planets, and gases in a galaxy. Everything we see in the cosmos, including our planet, the sun, the stars, and the galaxies, is composed of atoms, which are bundles of protons, neutrons, and electrons. The physics community has amassed a wealth of information about the underlying particles and forces that shape everyday stuff. Apples fall from trees for the same reason that Earth orbits the sun. And it has been known for centuries that Earth is not the center of the universe. The image is understated and sophisticated. The search for answers to the universe's most fundamental questions has come to a turning point. The results of astrophysical and cosmological observations show that we have an inadequate understanding of the cosmos. The major goal of NASA's September 5, 1977, launch of Voyager 1 was to investigate the outer solar system, Its initial mission was accomplished in 1980, and since then, it has been traveling into interstellar space. It has a current distance from Earth of almost 22.5 billion kilometers and is moving at a speed of about 17 kilometers per second. Since Voyager 1 has left the heliosphere, an area of space governed by the Sun's magnetic field and solar wind, it is free to explore the rest of the cosmos. The area between the stars, known as the interstellar medium, is a new realm it has entered. The scientific community was astounded when Voyager 1 recently discovered a faint humming sound emanating from beyond the heliopause in 2021. The 3 kHz sound is a continuous repetitive drone that has been compared to a hum or whistle. The device aboard Voyager 1, called the Plasma Wave System, which measures electric and magnetic fields, was the first to pick up the sound. Interstellar gas, the thin and rarefied gas that fills the interstellar medium, is thought to be the source of the sound. The hum is too low in frequency for human ears to pick up and is also too weak. But researchers have turned the information into a faint hum that can be heard. The next obvious question is what this finding means. What can we learn about the interstellar medium and the cosmos from this rumble? First off, the discovery proves that Voyager 1 has actually departed the solar system and is currently traveling in interstellar space. For the first time, a consistent and persistent signal from beyond the heliopause has been found, providing information about the interstellar medium's characteristics. Second, the hum gives us a new tool to investigate the characteristics of the interstellar medium. Scientists can determine the density, temperature, and other characteristics of the interstellar gas by measuring the frequency and amplitude of the hum. This will make it easier for us to comprehend how the physical characteristics of interstellar space affect galaxy formation and evolution. The scientific community is also faced with new problems and questions as a result of the discovery of the hum. For instance, the origin and production of sound are mysteries to scientists. They are also interested in the origin of the sound's 3 kHz frequency and whether it changes through time. Some scientists postulate that the interstellar hum may be brought on by the interaction of the interstellar medium with other radiation sources, such as cosmic rays, while others propose that it may be the result of the interstellar medium's interaction with the Milky Way's magnetic field. It is also intriguing to consider whether other telescopes or spacecraft can pick up this hum coming from various parts of the interstellar medium. This would aid in our understanding of the interstellar gas's characteristics and spatial distribution. The discovery of the hum also emphasizes the significance of continuing interstellar space exploration and study. Our knowledge of the solar system and interstellar space has already been fundamentally altered by the data returned by Voyager 1, and there is still much to learn. Future missions and instruments will definitely shed more light on the universe, and the hum is only one of the many mysteries still to be solved. Additionally, the Voyager 1 spacecraft returned some odd data from interstellar space that has NASA experts baffled, the so-called Attitude Articulation and Control System, or AACS, the onboard apparatus that monitors, reports, and modifies the position of the vehicle in space, provided the incorrect data. The system maintains an antenna pointing at Earth so it may transmit data back home. The strange circumstance raises concerns about the mission's long-term viability. The restrictions appear to still be in place, given that Voyager 1 is still sending data back from its scientific instruments, despite the fact that the data doesn't make sense, according to the U.S. Space Agency. Otherwise, it appears to be operating normally. Could alien intervention be the cause of this issue? What do you tell a highly advanced alien race on behalf of everyone on Earth? Or at the very least, how would you sum up humanity for the benefit of anyone who might be listening? This was the question asked by Carl Sagan and the group he put together to create the Voyager Records content. Both of the Voyager spacecraft carry copies of the Voyager Record, which Carl Sagan referred to as a cosmic greeting card in a letter to Alan Lomax. Sagan had earlier worked on a message that was sent on Pioneer 10 and 11, the the first NASA missions to escape the solar system. Plans for messages that would accompany the Voyager missions were significantly more elaborate. In essence, the spacecraft carried the Voyager golden records, sounds and pictures that depicted the variety and civilization of life on Earth. It was really a 12-inch disc that was covered in gold plating, and it was constructed in such a way that any sentient creature could readily understand the data on it. For instance, to the Voyager golden records, scientists added a broad variety of natural sounds, like wind, thunderstorms, sand, rain, etc. Additionally, they included noises of numerous animals, singers, children, different languages and pronunciations, and any other sound you can imagine. They also included a ton of photographs, including portraits of renowned people, the solar system and its planets, varied landscapes, scientific and mathematical values, and more. In addition to these pictures and noises, the spacecraft had a number of other odd items aboard them, including a letter from Jimmy Carter, the President of the United States at the time, and the inspirational Latin phrase, per aspera ad astra. It means, through hardships to the stars in English. It was, however, written in a distinct tongue, or perhaps a code, known as Morse code. Moving forward, the following are the two basic justifications for the production of these records. First, to establish communication with any intelligent extraterrestrial life that may exist in the universe. Secondly, made as a time capsule to help future generations and individuals from other eras understand the past and provide information for scientists who study history, archaeology, etc. The prospect that aliens or other intelligent life forms discover these documents raises a few more questions, which are, of course, if they do so at all. How will they get in touch with us and locate its source, the planet Earth? How will they be able to locate us in space? Human minds have already solved the issue of this possibility if any sentient species do discover these recordings, as many scientists believe is probable in this huge universe of ours. In this scenario, the finders will be given a step-by-step manual to help them decode the spacecraft's encoded message. The readers will then have little trouble locating Earth's location in the cosmos, or, as Sagan would prefer to put it, a pale blue dot in the vast expanse of the universe. They will also be able to contact us in a number of additional methods, all of which have been predefined for those who might stumble onto the records. The encoded messages included in these recordings, however, are challenging for an extraterrestrial culture to decipher, as several scientific researchers have discovered in recent investigations. If so, it is, to put it mildly, pretty disappointing. On the other hand, if alien civilizations do exist, our technology might be considered advanced by comparison. The world feels closer than ever to proving the existence of extraterrestrial intelligence since the U.S. government publicly disclosed evidence verifying the reality of unidentified flying objects, UFOs. Although we're not there yet, Michio Kaku believes there is no other option because scientists are starting to take them more seriously. Kaku believes that even if we don't fully understand the UFO phenomenon, we shouldn't rule out the idea that extraterrestrial intelligence is responsible for the enigmatic objects and that they could originate from extraterrestrial planets. Meanwhile, Michio Kaku is hesitant when it comes to contacting an alien culture, should we find one. I think that's a terrible idea. We all know what happened to Montezuma when he met Cortez in Mexico so many hundreds of years ago. Now, personally, I think that aliens out there would be friendly, but we can't gamble on it. So I think we will make contact, but we should do it very carefully. Maybe he has reason to be concerned. A UFO controlled by an alien intelligence would suggest that there is a risk associated with contacting them, according to Nature editor Mark Buchanan. But many astronomers are pushing up their efforts to make contact with any extraterrestrial civilization because they are enthusiastic about the prospect. The James Webb Space Telescope's hunt for habitable exoplanets, where further life may still be discovered, is one of its objectives. However, There is a big distinction between the actively communicating alien intelligence, or METI, which faces far greater criticism, and the passive search for extraterrestrial intelligence, or SETI, which is rather uncontroversial among astronomers. In 1974, a team of astronomers used the Arecibo Observatory radio telescope to send a message to the 25,000 light-year distance star cluster M13 in an effort to greet the rest of the cosmos. Unless you've overdosed on credulity and think that two crop circles that were discovered in an English field in Hampshire in 2001 already constitute the Arecibo answer, it will be many thousands of years before we can anticipate any sort of response. Since then, a number of probes have made one-way trips outside of our solar system to spread the word about humanity. The study of origin of life and life beyond Earth is pursued by astrobiology, which is sponsored by NASA and other space agencies. In order to communicate with extraterrestrial civilizations, METI International, a non-profit research and teaching organization, was established in San Francisco in 2015. 2 years later, it sent a message to the red dwarf Luyten star, located 12 light-years away, that contained mathematical calculations and Jean-Michel Jarre music. President and creator of METI International, Douglas Vakoch, contends that if extraterrestrials were intelligent enough to travel great distances to Earth, they wouldn't likely require any of our resources. So we shouldn't be reluctant to start a cosmic dialogue. Fear simply limits us, he claims. It does not protect us. Jeff Hawkins had the intriguing notion that we could launch some enormous orbiting sunblockers to announce our presence on Earth in his book 1,000 Brains. A message in a bottle would be sent to the rest of the galaxy by these blockers, which would orbit the sun for millions of years and cause minute, artificial, observable reductions in brightness. All human efforts to make contact with aliens, however, present serious concerns. Who gets to represent Earth in these discussions? What message do we want to convey? Therefore, the question boils down to this: does humankind's thirst for knowledge outweigh its dread of the unknown? Which, we could argue, has been answered definitively over the course of many centuries of human history.